Hi, welcome to page 2 of section 7.3, where here we're going to solve two differential equations. The first being example 5, where we have y double prime minus 4y prime plus 4y equals t cubed e to the 2t. So here I know I'm going to use, look at the forefront, I'm going to be able to see that I have some function t cubed times e to the 2t. So it tells me that, okay, I'm probably going to use the translation on the s-axis to go ahead and finish solving for this. So we have the initial value of y of 0 is equal to 0 and y prime of 0 is equal to 0. So the first thing we're going to do is we're going to go ahead and do the Laplace transformation to both sides. So on the left, if we do the Laplace transformation on the left, we're going to get the Laplace transform of y double prime minus 4 times the Laplace transform of y prime plus 4 times the Laplace transform of y is equal to the Laplace transform of t cubed e to 2t. So we just take the Laplace transform to both sides. Now, if you recall from the last section, when we do the Laplace transform of y double prime, it's s squared times cap y of s minus s times y of 0 minus y prime of 0 minus 4 times the Laplace transform of y prime is just s times cap y of s minus y of 0, and then the minus 4 Laplace transform of y is just plus 4 times cap y of s is equal to, when we do the Laplace transform of the right side, we're really looking at t cubed. If we look at t cubed, that's just going to be 3 factorial over s to the 4th. So 3 factorial is 6. But here we have the e to the 2t, so we need to make sure that we incorporate that. So it's just s minus 2 to the 4th. Now, on the left-hand side, we're going to substitute in our values, our initial values of y of 0 is 0, y prime of 0 is 0. So we substitute those in. Those are just 0, so a few things are going to cancel out. So on the left-hand side, we're just left with s squared times cap y of s minus 4s times cap y of s plus 4 times cap y of s. Because we want our cap y of s by itself, we pull out the cap y of s, and we're left with this quadratic s squared minus 4s plus 4. Well, we can go ahead and factor that to just s minus 2 squared. And we're going to divide both sides by that. So we're going to divide the left side and the right by that, and we're going to get cap y of s by itself. So we get 6 over s minus 2 to the 6th power. Now, we want to solve for cap y of s, and we want to get back to our original y. So now we have to do the inverse Laplace transform. So we do the inverse of the left side of y of s is just going to give us y of t, so that's not bad. But when we do the inverse Laplace transform to the right, what we're going to do is we're going to pull the 6 out, and we're going to just look at s minus 2 to the 6. We're going to change s minus 2 to just be s, and we're going to show that we have that there. S is s minus 2. And because we have 6 to s to the 6th power, the factorial that we needed on top was 5 factorial. So we need to make sure that we take that out. And so when we notice, hey, I have 5 factorial over s to the 6th, oh, that tells me that I had original t to the 5th for this part, and then this the s being s minus 2 gives us e to the 2t, because that's our a value. And then 6 over 120, which is just going to reduce to 1 over 20, and then e to the 2t times t to the 5th, and we're finished. Now, again, next we're going to have another differential equation. It's a second order differential equation where we have 2y double prime plus 20y prime plus 51y is equal to 0, with the initial value of 2, and for the derivative, the initial value of 0. And so again, we're going to do the same thing. We're going to take the Laplace transform of the left and the right side. When we take the Laplace transformation of the left, we're going to get 2s squared times cap y of s minus 2s times this 2 comes from the y of 0 minus 0 plus 20 times s cap y of s minus 20 times what y of 0 was, which is 2, plus 51 times cap y of s equals 0. So then, on the left, when we solve for this, we're going to get everything that has a cap y of s on the left-hand side together. Anything that doesn't, we're just going to put on the back end of the left side. And so we're going to get rid of the minus 4s minus 40 because we want to solve for cap y of s. So we're going to add 4s plus 40 to the right. And on the left, we're going to go ahead and pull out all of the coefficients with our cap y of s. And we're left with 2s squared plus 20s plus 51. And so cap y of s is equal to 4s plus 40 over 2s squared plus 20s plus 51. And now, all we need to do to solve is take the inverse Laplace transform of both the left and the right. Well, the left, when we take it of just cap y of s, we're just going to get y of t. But on the right, there's a problem. Since we have a fraction, we're hoping that we can factor the denominator and do then what we can do is hopefully do partial fractions. The problem with this is that this does not factor evenly. Now, because this does not factor evenly, what it tells us what we're going to have to do is we're going to have to complete the square, just like in example 4. Now, when we have to complete the square for problems like this, that's when we know, oh, hey, we had to do the s minus a. And so what we're going to try to do is try to write something where we can do s minus a. So the first thing that we're going to do is, in order to complete the square for this, let's go ahead and get rid of this 2. So we're going to pull a 2 out. So we're just left with s squared plus 10s plus 25.5. Now, it's okay to have that fraction. Trust me, it will work itself out. Now, when we notice that we have s squared plus 10s, to complete the square, we need a 25. So we're going to break up the 25.5 to 25 plus 1/2. And now we can go ahead and factor this to be s plus 5 squared plus 1/2. And so now our denominator is just 2 times s plus 5 squared plus 1/2. Now, on top, we have 4s plus 40. So this 2 will go ahead and reduce the numerator sum to be 2s plus 20. Now, what we want, because we have an s plus 5 in the denominator, we want an s plus 5 in the numerator. And because we have that 2 there, what we want to do is, well, hey, is there something that I can take out by 2 and give me this 5? A 10. So really what I'm going to have up here is 2s plus 10 plus 10. That way I can pull out a 2 and get an s plus 5, and then I have this 10 hanging over there. And now what I'm going to do is separate this fraction, where this is my left part of the fraction and this 10 is going to be the right part of the fraction. And now I'm going to go ahead and pull this 2 out to where I have an s plus 5 in the numerator and s plus 5 in the denominator squared plus 1/2. And so when I notice, oh, I have an s in the numerator and s in the squared in the denominator, that's going to be cosine, and s is just s plus 5. So I break it up into, when I do the inverse Laplace transform this, I know, so hey, that has to be cosine. And so since my a is -5, it's 2 times e to -5t plus cosine of t over the square root of 2. Now notice here, my k is 1/2. If I remember, this is k squared, so k squared is 1/2. So that means k is the square root of this. Well, the square root of 1/2 is just 1 over the square root of 2. And so that's why inside my cosine is t over the square root of 2. Now on the right side, I'm going to pull out this 10 because what I want in the numerator is, either an s or my k. In this case, 10 is not the s or the k. The k, remember, is going to be 1 over the square root of 2. So I'm going to pull out the 10. I need to put a 1 over the square root of 2 on the right. So that means I got to multiply by the square root of 2 on the left to get what I need in the numerator. So now that I have my k in the numerator, what I can do is take the inverse Laplace transform of that, which is going to be sine of t over the square root of 2 times e of negative 5t, because a is negative 5, and 10 times the square root of 2 because I had to incorporate that square root of 2 because of my k.